Welcome! In this video, I'm going to show you how to draw a motion map for an object that is accelerating. So a situation in which something might accelerate would be when a car, like a physics cart, is set at the top of the ramp, and if it's left free to roll down, it will speed up as it rolls down to the bottom of the ramp. So we've drawn motion maps before, but for objects going at a constant velocity, this was a more straightforward situation. Now, I mentioned that the car is starting at rest at the top of the hill. So if the car is starting at rest at the top of the hill, I'm going to draw a dot. Remember, this corresponds to where I pushed start on the timer. So this is actually a dot for time 0. So that's where the car started. And I am using blue here to show the car's velocity as it travels down the hill. Now, as something goes downhill, it's going to get faster. We'll kind of be taking pictures of the car. Imagine as taking pictures every second. So in the first second, the car's not going to go very far. In the next second, it'll go a little further. It'll go further still in the third second, and so on until the car is at the bottom of the hill. Now, same as I did with my motion maps for constant velocity objects, I'm going to draw an arrow roughly half the distance between the consecutive dots, and the arrow should point in the direction that the car was traveling. So in this motion map so far, I've shown the velocity of the car as it goes down the hill. Now, what changes when the car is going downhill is that it's not just going at a steady speed, it's actually accelerating. And so we're going to add a second set of arrows to show the acceleration of this car as it goes down the hill. Now, just a quick refresher, we have defined acceleration. We use a lowercase a for acceleration, and it's defined as an object's change in velocity divided by its change in time. That is how much velocity changes per unit time. Now, in this example, because on motion maps we usually draw our dots 1 second apart in time, it's basically like the bottom of that equation is 1 second on a motion map. So we're really just going to be drawing arrows for acceleration to show that acceleration is proportional, or in this case, if it's 1 second, equal to the change in velocity that the object experienced. So in the one that I had just drawn, I started with a dot, and right after that, the object had a velocity. So it went from no velocity to having a little velocity. Well, how much did the velocity change by? One way to do that is if I take this little arrow that I had, and I have another copy here, and move it back to the original. Well, how much bigger did that one get? It got that much bigger, right? Because it was a dot, it had no arrow, and then it was an arrow, okay? Now, if we think about the next one, that was on our motion map before, okay? Now I need to look at going from the second arrow to the third arrow. So the question I again ask is, well, how much bigger did it get? Well, in this case, it only got a little bit bigger, right? It only went from here to there. That's how much bigger it got. So you're always looking at the difference between consecutive arrows to draw your acceleration. Okay, so let's go back to the original motion map that we were looking at. So we had this car going downhill. Its velocity was getting larger as it went downhill. And now we need to add acceleration arrows to show how much its velocity was changing by. So similar to what we did before, we're going to imagine taking this arrow that was next, put it back next to the original one. That's how much bigger my velocity got. So I'm going to draw another arrow, and you'll notice I'm choosing to use a different color just so that this is a little more visually clear to show how much the velocity changed by. Now if I look one arrow down the road, I have this guy, okay? So I can pull that over and look at it compared to the other one. So it got this much longer. So I'm going to draw an acceleration arrow starting at the same point as the previous velocity arrow to show how much larger the next velocity arrow is. And I could do that on, and what you will end up with is this sequence of arrows going downhill. Now, one thing that you may notice is that my acceleration arrows are all the same length. And this is because our car on a hill is experiencing something called uniform acceleration, meaning it has the same amount of acceleration every second. Okay, and that's why we see arrows of equal length. Now we're going to look at one more situation before the end of this video, and the situation I want to consider this time is a car that instead of rolling downhill, the car is now actually going to start at the bottom of the hill, and my car's backwards, but it's going to be pushed up the hill, and then it's going to roll back down. And we'll actually only look at it going uphill, so we'll look at the car just going uphill. So the car is going to start at the bottom, and in order for the car to go anywhere, I would have had to give it a big push. So the car is going to start with a pretty large velocity at the bottom of the hill. Okay, as it goes uphill, as with any object, it's going to slow down. So I'm going to draw arrows that are shortening because the velocity is decreasing, until up here where it would come to a stop. So at time 0, it was moving fast uphill. Time 1, 2, 3, 4. 4 seconds later, the car is now stopped at the hill. Now, this is going to be a little bit trickier. If we compare the first two velocity arrows here, right, I have a pretty long arrow for that initial velocity, and then my next velocity arrow got shorter. So I have about this length of an arrow, right? So I went from a bigger arrow to a smaller arrow. Well, how can that happen? Well, I would have had to lose some velocity. So in order to lose that velocity, my acceleration actually points in the other way. So another way to think about it would be this original arrow plus that acceleration. So initial velocity plus acceleration will give me my next velocity, okay? So I'm going to draw in my acceleration here. So showing just that it has a small backwards acceleration. Now same situation with the next set of points, right? In the second second, the third dot, I'm a little shorter than I were before. So in order to have gotten a smaller or shorter velocity, I had to lose some velocity, meaning my acceleration was pointing in the opposite direction. And this is true all along the ramp. So we see again that my acceleration arrows are all the same length. Meaning that there is uniform acceleration. And we also see something interesting, that my car slows down and there's one important detail that tells us the car slows down. The velocity and the acceleration arrows point in opposite directions. And you'll notice if we come back to the very first one that we had done, in this first one, the arrows pointed in the same way, and that meant the car sped up. So that's a really important detail that we're going to reiterate through some lab experiments this unit as well.